Hello. So, we will continue our discussion on cloud computing. Today, we will look at one aspect of or on one application of this cloud computing, or would we say that amalgamation with other technology. What we look at is a mobile cloud computing. Though mobile cloud computing itself has now become a topic or subject as a whole, but we will try to look at the different aspects of mobile cloud computing, basically overview of the things that what are the different features, characteristics, where is the need and so on and so forth. So, as we see in today's world, these mobile devices, or what we say smartphone devices or smart mobile devices, have a huge proliferation in our society, right, from different category of people to different level of application and so on and so forth. So, that has created a revolution in the communication path. So, there are a couple of things. One is that this huge proliferation is possible or because of easy availability or low cost high bandwidth availability at the back end. So, there are service provider or back end service providers which provides networking to these devices. Secondly, we also have a scenario that with very resourceful, so to say quote unquote resourceful in the devices are coming up, which are much resourceful than yesterday's devices, right. So, there is a upliftment of the resources, still that is not matching with the type of things which we have on the desktop or other type of servers, but nevertheless it is a resourceful device. It is a smart device, it has capability of lot of sensing and running lot of apps, and you have a backbone networking which allows you to communicate in a bigger way. So, all those things has given up a trend that whether I can use this device for computing purpose, right. So, or if I have some applications which is running which require some good amount of computing, where there is a provision of uploading this sort of computing activity to some other more resourceful equipment or something. So, here there came as a natural need of that interfacing between the cloud and mobile devices, right. So, that mobile devices if it can offload its some of these computing phases or computing modules to the other to the cloud and get it back and go on running, that could have been a marvelous thing, right. Like I can say that I am sensing some information about environmental things, then I want to do a predictive model that what is going to be there, very short term prediction, and then that predictive model requires a much more resources than sensing and doing in some initial analysis. So, what I do that this thing is offloaded to a much higher resourceful infrastructure, say cloud, and I get the results and analyze the result at my end or with other collateral data. So, there can be lot of type of applications which involves some sort of a data analysis, data analytics which could have been offloaded or things. So, this sort of amalgamation, whether it is possible, what sort of architecture is there, what are the different type of challenges that we would like to look at in this lecture, maybe one or two consecutive lectures. So, today we will talk about basics of mobile cloud computing, what are the things. So, what we see, what motivates, as we are discussing, there is a huge growth of smartphones or uses of the smartphone, and not only the phone, of smart applications, right. Increased capability of the mobile devices in terms of running these applications and resources. Access of internet mobile devices became pretty easy, like is connectivity of these mobile devices with the back end internet networking. Resource and on the other hand, there are some of the things resource challenges like battery life, storage, bandwidth. These are some of the resource challenges if the application is heavy that is more require more resource to execute this, or what we say resource hungry applications, right. So, in mobile devices, cloud computing on the other hand offers advantage to the users by allowing them to use infrastructure platform software by cloud providers as a low cost and elastically in an on demand fashion. As we have seen that the cloud computing on the other hand provides the user with a low cost elastic service like as pay as you go model, and whether there is a possibility of amalgamation, exactly what we are trying to say when we talk about mobile cloud computing, or sometimes abbreviated as MCC, right. So, to have something mobile and something at your fingertips while you are moving. So, something what we trying that mobile backend as a service type of things, like as we try to do everything XaaS type of things, like anything as a service. So, why not mobile backend as a service? Like, so what when we look at it, it provides a mobile application developers a way to connect to their applications backend cloud provider and cloud storage and processing, abstract away complexity of launching, managing own infrastructure, right. That is a need. Focus more on the front end development instead of the back end functionalities, right. So, that it is more on the how these apps will be developed, rather looking at that how my back end, how to manage the back end and so on and so forth. So, multiple apps, multiple back end, multiple developers, things are possible, multiple mobile platforms, multiple integration, multiple third party systems and type of things. So, that means there is a integration of multi party type of systems, and meaningful resource for app development like third party API, device SDKs, enterprise connector and so on and so forth. So, there are different what, why, when, how type of things which there is a possibility of answering this type of situations. Now, augmenting these mobiles with cloud computing, there are several efforts or initiatives like Amazon Silk browser, which is a split browser, Apple Siri, Apple iCloud, image recognition apps on smartphones useful in developing augmented reality apps in the mobile devices. So, all those things at the back end it talk to a cloud, right. So, it may be for storage, it may be for computing, it talk to a cloud. The things are possible primarily because you have a intermediate high bandwidth scenario, right. So, that you seamlessly think that as if the calculation is working on the mobile device. So, that this type of delay can be materialized, can be handled, right. So, whenever I offload any application or any computing things to some other things, so a couple of things come into play, right. One is that there should be a fill of that as if the application running on the device itself. So, that means intermediate delays in offloading. So, this particular portion of the application, the whole application should be minimal, right. There are other things like if I want to do a dynamic offloading, then I need to do lot of things like I need to appropriately partition the things, need to have a lot of synchronization into play, and if there are dependencies with other applications, those has to be taken care. So, this is not a straightforward scenario, there are lot of complexity involved in it, and lot of timing relationships and other things come into play, right. So, if it can be managed, then we can have a scenario things like computing. So, if you try to look at what mobile computing is as a definition, there are a number of definitions available across the internet, few we are trying to look at. So, it is a combination of cloud computing, mobile computing and wireless network, intermediate wireless networks to bring rich computational resources to the mobile user. So, that is one of the aspects of the thing. So, MCC provides mobile user with data storage and processing services on cloud. So, it provide mobile users with data storage and processing service, that primarily the two things. So, other thing is that moving computing power and data storage away from the mobile device. So, in other cases what we do that I detach this computing power or migrate this computing power and the storage to this cloud infrastructure. So, these two primarily things are there, and we can say it is a combination of cloud computing, mobile networks to bring benefits of the mobile users, network operators as well as the cloud providers. So, it is a some sort of a what we quote unquote win-win situation to have all those things. So, why computing, mobile computing or MCC? This is well understood. First of all, what we look at the speed and flexibility. Mobile applications can be built on or revised quickly using the cloud services. So, two things are there, that I can have a lot of speed up on the things, right. So, computing as cloud are more resourceful things, it can be do immediately. There is another thing is that if there is a upgradation needs and something has to be there, like suppose I am using a algo for finding a minimum path or minimum distance between point A and point B on a typical map, then I can if there is a new heuristics come up, I change at the cloud end, and it is seamless for my front end application at the mobile device whether to how to offload on the cloud. It is only the duty to offload the things, the rest is calculation is there, right. So, based on the different situations or different scenarios, I can have different algos and things coming up, and so it is something a detaching that actual processing from the devices. So, it is both flexible and speedy thing. Shared resources, I can use shared resources. Mobile apps that can run on cloud are not constrained by device storage and processing resources. Data intensive processes can run on the cloud. User engagement and continuing seamless processes can run on the devices, right. So, so what we say that some of the things need to be run on the mobile devices, some can be offloaded. That type of dynamic DES and partitioning is still a major challenge, right. And integrated data, mobile cloud computing enables users to quickly and securely collect and integrate data from various sources regardless of where it resides, right. Like I want to do some sort of a disasters management type of thing. So, so if there is a disasters management system, so on very quickly lot of data need to be collected by different sensors which are mobile based and need to be run to see that what sort of other what sort of mitigation techniques to be there. So, there can be lot of applications which run at the back end which is in the cloud and can be integrated seamlessly along with this with the different sort of heterogeneous data sets. So, if we look at the key features, the cloud computing delivers application to mobile devices quickly and securely and capabilities beyond those of local resources, like facilitates quick development, delivery and management of mobile apps, uses fewer device resources because the applications are cloud supported. So, I have less device resources or I am less loading the device resources, it is less battery power, less heating up, and you can run a lot of other apps into the thing, right. Supports a variety of development and approaches, and devices. Mobility as it is doing at the cloud end, so that it can a same type of computing thing can support number of apps. So, that means easy to standardize across the things or running the reusability of some applications or reusability of algorithms is much higher. Mobile devices connect to services delivered through an API architecture, improves reliability and information backed up and stored on the cloud, right. So, it is not device dependent. Suppose you store the data at the device, if the device goes down, then the whole thing goes down, but if I have a storage in the somewhere in the cloud with the other reliability into the place, like it has reliable storage facilities, then my my information is more reliably stored and can be handled. So, if we look at, so one end is this mobile devices or smart mobile devices, sometimes we abbreviate as SMD, other end is a computational cloud, and in between we have a wireless network technology provided by the service provider, right. So, mobile cloud computing is a framework to augment resource constrained mobile devices to execute parts of the program on the cloud based servers, right. So, that is there, though one can argue that these days mobile devices are much resourceful, but there is no match with the type of resources a cloud or a cloud based servers can provide, right. So, there is absolutely no match on the things. So, that means you can run now more powerful or more resource hungry applications into the device. So, there are pros like saves battery power as you are doing less computing, makes execution faster at times if you have a good bandwidth and type of things. There are definitely the flip side of it, must send the program state, data or the state and data and the cloud server, hence consume battery, right. So, it is additional loading of transferring data. Network latency can lead with execution delay. So, if there are latency, so there can be execution delay into the system. So, this is a overall big picture, a flow chart. So, if you see, there is one part is related to the mobile devices, other part is more on the cloud computing things and how this workflow will go on. So, there are mobile apps. So, there should be a profiler which profiles this different that particular app and devices. There is a solver of which takes care of that, how this if I partition these and how it need to be profiled to be sent to the things, then how solving will be there. That is a SMD synchronization. SMD stand for smart mobile devices, device and synchronizer, that because if you partition and execute in the on the cloud, then we need to take care of the how this synchronization process will go on. And there is mobile node manager, right, to takes care that it sends the data to the cloud, captures the data and how things are managed. On the cloud end, we have the cloud data center and server nodes, which are already we have seen, we have discussed a lot on those things. That so, for the cloud it is a some sort of a third party application, or what we say that some third party user request coming to the things need to be executed within a particular QoS, within QoS and serve with some SLAs and need to be served, right. And in between we have a wireless media which plays a important role, though it is neither computing or giving directly doing anything with the app, but it plays an important role in the sense that it takes care of this latency, right, or it need to take care of this latency. So, if we look at the runtime offloading, there are different tricky issues, right, or factors like dynamic runtime offloading involves the issues of dynamic application profiling and solver on SMD, right, runtime application partitioning, you need to partition the its runtime, migration of intensive component like which are computational intensive component need to be migrated, continuous synchronization of the entire duration of the runtime execution platform. So, so long it is running, we need to synchronize the things. So, if you look at these are very tricky issues, right. These are not any straightforward things. Anything doing dynamically runtime is extremely challenging, right. And so, dynamic application profiling and solver in the SMD on the mobile device, runtime application partitioning, you need to partition on the runtime, migration of intensive components and continuous synchronization of the entire duration of the runtime execution platform. So, there are major issues which need to be addressed or which are being addressed when you develop this type of mobile computing, cloud computing apps. There are several components, some of the key components. One is this profiler, so which monitors application execution to collect data about the time to execute, power consumption and network traffic. Solver has the task of selecting which part of an app runs on mobile and cloud. So, it need to look at that which need to be running at the mobile end and which need to be offloaded at the cloud end, that the one of the major duty of the solver. Synchronizer, task of synchronizer module is to collect results of split execution and combine and make the execution details transparent to the user. So, that is important, right. You have partitioned the things runtime and the split execution things need to be again stitch together and give a user some feeling that as if its application was running seamlessly on the device and without any much delay and type of things. So, this is also a very major challenge in handling this. So, there are other components like requirements, what we see that simple APIs should not be very cumbersome, so that user is inclined to use it. So, simple APIs offering access to mobile devices and requiring no specific knowledge of underlying network technologies, right. So, it should be the user should not be burdened with the knowledge of network technologies and knowing all those things. Web interface, should we should have a appropriate web interface. Internet access to remotely stored applications in the cloud, right. So, you should have internet access to remotely stored application in the cloud. So, that is there. So, if we look at a typical architecture, so one side we have mobile devices, one side this cloud computing environment, and there are different service provider which provides the network backbone, and there are internet services to connect to this cloud, right. So, for the cloud it is more of a giving appropriate user interface for connecting this mobile devices or the applications which are offloaded by the mobile devices onto the cloud. So, there are mobile user, network operators, internet service provider and application service provider. So, this which need to be appropriately working in sync, right. So, mobile devices are connected to the mobile networks via base stations and establish and control the connection of functional interface between the network and the mobile devices. Mobile user requests the information. So, one is that more devices connected to the base net station, and mobile user requests the information are transmitted to the central processing and are collected by the server providing those things. So, that has to be are transmitted. So, there is a transmission of the data. The subscriber requests are delivered to the cloud through the internet, right. The subscriber should be transparent to that. In the cloud controller process the request to provide the mobile user with the corresponding cloud services. So, based on the request that cloud controller process the thing, so that it can give the mobile user the requested services. So, there are several advantages already we have looked into few of them, and one is that extending battery lifetime. So, as you are offloading some computing thing and which is if it is resource hungry, then in a sense you are saving energies and battery lifetime. Computation offloading migrates large computations and complex processing from resource limited devices, that is mobile devices, to resource full machines, that is servers in clouds, right. Remote application execution can save energy significantly. Many mobile application takes advantage from task migration and remote processing, right. So, those are help in saving battery lifetime. Improving data storage capacity and processing power, right. So, if it is as it is stored on the cloud end with a huge amount of data storage capability. So, it improves that data storage capacity, right. I can go on continuously go on take data, say I am going on taking environmental data. So, and offloading it. So, that is no loading on my own devices. So, that is a advantage of the things, and of course, I have a huge processing power at the back end, right, provided my network latency is within the permissible limit, right. Improve reliability and availability, right. So, that keeping data and application in the cloud reduces the chance of loss of the data along with the mobile devices and things, if there is a loss things are there. MCC can be designed as a comprehensive data security model for both service provider and users, though there are a lot of security issues, but can be designed to look into, like protect copyrighted digital content in the cloud or provide security services such as virus scanning malicious code detection, etc. With data and services in the cloud, then they are always available within the when the users are moving, right. So, that is another thing is that. So, if as the data and services are offloaded to the cloud, so they are omnipresent, right. I can have always wherever I am moving, whether this device, if I have a sync with the other device or other things are accessing. So, it is always available in the thing, some sort of a having a centralized vision of services or processing services and data can be looked into. So, there are other advantages like dynamic provisioning. So, I can dynamically provision the things, scalability issues like as whatever is provided by the cloud, that is infinite scalability, multi-tenancy like service provider can share the resources and costs to support variety of application and large number of users, like as there is a property of the cloud of multi-tenant. Ease of integration, multiple services from different providers can be integrated easily through the cloud and the internet to meet the users demand, right. So, that I can have standardization one place, I can connect different devices and type of things in through the cloud, and I can have integration of the things. There are several challenges. One major challenges, as we see in other cases also, is security issues, right. So, protecting user privacy and data application secrecy from adversaries is a key to establish and maintain consumer trust on mobile platform, especially in case of mobile cloud computing, right. So, how my data processing things are protected from other adversaries or attackers is important. Otherwise, at least when I work on the devices, I somewhat have a much larger trust on the devices, but if I once I offload, I do not know that what is happening. And most of the cases I am not subscribing to the cloud itself, I am subscribing to the service provider and the whole paradigm, right. It is offloading to the cloud. It may so happen that the whole framework may select different cloud based on the availability, pricing and different other factors, right. So, it is sometimes becomes tricky issue on the security point. So, MCC security issues have two major categories like security of mobile users and securing data of cloud. So, privacy also plays an important role, because in doing so it is not only the data of the mobile user, but also my concern may be that my identity, my mobility, my GPS footprints are being tracked, right. So, there are several issues. Security and privacy of the mobile user, that is why is a major issue. So, mobile devices can expose numerous security threats like malicious code, and these GPS can cause privacy issue of the subscribers. There are location based services faces privacy issue of the mobile user provide private information such as their current location, etc. Problem become worse if the adversary knows the user's important information, right. And security of the mobile users approach to move threat detection capabilities on the cloud. So, there are different type of approaches. Host agent runs the mobile devices to inspect the file activity on the system. Attack detection on a smartphone on a remote server on the cloud, it can be there, like if there is a connectivity between the things. So, there can be a that can be adversely affect the mobile user. The smartphone records only a minimum execution trace and transmit it to the security server in the cloud, right. So, that is another problem. So, mobile cloud computing, there are other challenges like context aware mobile cloud services, right. So, this is context aware services of the mobile users, there are a lot of research is going on. Like it is important to fulfill mobile user satisfaction by monitoring their preferences and providing appropriate services to each of the users, right. So, different users, after all is a human being, has different way of looking at things. So, I need to categorize that what sort of users are which type of things, like some are maybe looking at more streaming multimedia things, some are more used to having some sort of a mail and data services and type of things. Some of the user may be running some scientific things like say data analysis type of thing. So, this type of different user has different type of need at the back end. So, the services based on that or based on the context need to be looked at, right. So, context aware mobile cloud services try to utilize the local context, that is the data types, network status, device environment, user preferences to improve the quality of services, right. Network access management is another challenge, like efficient network access management only to improve link performance and also optimizes bandwidth usage. So, what is this network latencies plays a major bottleneck. So, it is not only improving the bandwidth giving latency, but how to optimize those uses. After all, these are resources which are being used by several users, right. Quality of service is another aspect. Pricing is a tricky issue, right. So, there are number of parties now involved. It is not only the cloud provider, it is the mobile service provider also. So, how this price will be there, what should be the business model, and how to make use of the price, where a user will pay and what benefits is get, what is the SLAs and how things are served. Those are very tricky and very important issues and challenges. There are other challenges like standard interfaces, so that you can provide a challenge a standard interfaces or different applications, different sort of devices can work on it. Service convergence, services will be differentiated according to the type, cost, availability and quality. New scheme is needed in which the mobile user can utilize multiple cloud in a unified fashion. So, that is what we mean by service convergence. Service integrated, that convergence would need to be explored in order to achieve all those things, right. So, these are some of the important aspects of the things. So, what we see, definitely there is a need, and it is a increasing need, right. Day to day things are increasing, that you want to run more stronger application or resource hungry application on the mobile devices. So, we need at the back end something, a good infrastructure which can work on behalf of my devices, right. So, cloud is one of the definitely one of the option, one of the good option of doing that. And so, what we require this, there should be a seamless integration of these devices with the cloud service providers, and in between we have this network service provider or the who provides the mobile services and things. So, one side mobile devices, one side cloud, and intermediate this network services including internetworking, which can put all together to all of them together, and so that I can have a enriched applications or more resourceful applications running on devices and doing lot of other job for variety of users. So, with this we will conclude today. Thank you.